Resistance. We have seen street lights glowing in the streets during the night. We know that the lights glow because current passes through it. The current passes through the wires to the light. Why is that there is no light in the wire? This is because of the difference in the resistances offered by the bulb filament and the wire. Let us learn about resistance in this topic. The electrical resistance of an object is a measure of its opposition to the passage of a steady electric current. How does an electrical resistance occur? We have already known the structure of an atom and that the movement of free electrons causes electric current. Let's look at this process once again. When there is a potential difference between 2 points, electrons move from one point to another. This potential difference is created by a battery. In an electric circuit, the electrons keep on moving from one point to another. Now, let's add a resistor to the circuit. We can see that the electron flow slows down. Why? Let's take a cross section to understand this. Here, we can see the network of atoms that constitute the resistor. There is a network of positively charged ions which can vibrate. There are the free electrons which are capable of movement. When a potential difference is applied, these electrons move from one point to another. During this movement, they collide with the positive ions, causing them to vibrate more. This causes resistance. When resistance is less, the electrons can move from one point to another freely. When there is more resistance, there are more collisions and the movement of electrons gets restricted. Now, let's understand the factors on which resistance is dependent. The resistance of the conductor is dependent on the following factors. 1. On its length. 2. On its area of its cross section. And 3. On the nature of its material. First, let's take up length of the conductor. When the length of the conductor is greater, the distance to be covered by the electrons is greater, and hence there will be more collisions. There are also more ions to collide with, hence the resistance is greater. The larger the cross-section area of the conductor, the more electrons are available to carry the current, so lower the resistance. Also, there is greater space available for the electrons to move about. Notice that the electrons seem to be moving at the same speed in each one, but there are many more electrons in the larger wire. This results in a larger current, which leads us to say that the resistance is less in a wire with a larger cross-sectional area. Thicker the conductor, lesser the resistance, and vice versa. Resistance depends on the nature of the material also. In some materials, there are free electrons that can move about freely, while in some others there are no free electrons. When there are more electrons to move about, more current will flow and resistance will be less. In some materials like copper, there will be very few collisions and hence lesser resistance, while in some others like iron, there will be more collisions and hence greater resistance. Set up the circuit of a light bulb and a battery. We will keep changing the battery and see the effect on the bulb. First, let's use a 0.5 volt battery in the circuit. The bulb glows. Now, we will replace it with a 1 volt battery. We can see that the bulb glows brighter. Now again, we will replace it with a 1.5 volt battery. Now, we can observe that the light glows more brighter. Now, we can state that as we increase the voltage in the circuit, the potential difference of the circuit will vary and there will be a huge difference. This will make the electrons move faster. Have you ever wondered why copper is used in electric wiring? Why an iron rod conducts current while a piece of wood doesn't? And why resistors are used in an electric toaster? A copper wire has a very low resistance which allows for a smooth flow of current. As we have seen, greater number of free electrons and lower resistance to the passage makes material a good conductor. Also, copper is a good electrical conductor, provides a good contact surface, is ductile, and is not too expensive. Iron is a conductor and it offers lesser resistance to the flow of current than wood. Materials like wood and glass that do not allow the passage of electric current are called insulators. Insulators won't allow current to pass through it because they offer very large resistance to the flow of electric current. In an insulator, all the electrons are bound electrons, and as a result, there is no flow of electrons from one point to another. Resistors are used to produce heat in an electric toaster. When the current passes through the resistor, the electrons start moving. This movement will result in collisions. As a result of collisions, heat is generated in the resistor. Soon, the coil becomes hot enough to toast bread. In this lesson, we have learned the concept of resistance and the factors affecting the resistance of a conductor. Now we have some questions for you to think about. You might have noticed an electrician repairing a live wire using a pair of cutting pliers. Still, he does not get a shock. Why? We have all seen underground cables being laid below the ground. We know that these carry electric current. Why is that we do not get an electric shock when we walk above these? We know that resistance of the filament causes a bulb to light up. Now think about this. In a tube light, there are no filament, but light glows. How? Find the answers yourself.